All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. What we're going to be talking about over the next couple minutes is the properties of proportions, okay? So when we talk about things in Chapter 8, what we're dealing primarily with would be similar polygons. Now, I know all of you guys, and some of you may have heard me use this example before. When you go ahead and take a picture from a document and move it into another document, but you don't like the size of it, you usually click on the corner edge and increase the size or decrease the size. Now, the shapes look the same, they're just smaller or bigger than the original shape. They're not congruent to, they're what we call similar. And so when you think about similar figures, you're going to hear me talk a lot about this over the next couple of days. Not so much today, but I want you to understand why we're doing what we are today leading forward. It's this, that similar polygons have congruent corresponding angles, okay? All the angles have to be the same for the shape to look the same, but the sides aren't equal. They're going to be proportional. The corresponding sides are going to be proportional. And so that's why we're going to be working with the properties of proportions today. And so I want to make sure that I'm getting marks on. Okay, I want to make sure my computer was connected to my board there. So as you look at this first example here, guys, I know that you guys know how to solve proportions. I just want to review a simple concept that I don't want you guys to make this mistake moving forward, and that's this. When we go to solve a proportion, you guys know to cross multiply. So there and there. And that's really simple. But the hard part is sometimes when we cross multiply here, that's simple, 27y, but going here, we only multiply the 5 by one of these two terms. You need to multiply the 5 by both of those two terms. So as we look at this, I wrote it all out. We're going to multiply 9 times 3y, that's simple, and 5 times 4y minus 16. Now, notice the parentheses, I want to distribute that to both of them, okay? And so from there it becomes a very simple algebra problem, and I'm pretty sure that you guys can solve those. So what I'd like you guys to do is to actually go ahead and solve numbers 2, 3, and 5 if you haven't already done that, okay? Now, I will be honest. As I go over this stuff, a lot of it's review from algebra and probably 8th grade and 7th grade all thrown together in this one lesson here. So it's important that we recover this stuff to make sure you're good, all right? But as you look at things moving forward, okay, as we look at these proportions, I need to make sure that you know what you're doing. So if I were you, I would actually go through and do the entire two sides, okay? And then come back and watch the video, or at least watch the answers on the video. If you get a problem wrong, then I would go back through and say, okay, what did he do here? And listen to me talk things out. It'll be a lot quicker for you if you do that. Now, if you get to the back side, or even you're going through these and you have no idea what's going on, then you probably should listen to the entire video and go from there. So, with that being said, let's go ahead and look at numbers 2, 3, and 5. Again, if I were you, I would pause my computer and do it myself and then look back. But if I go ahead and cross multiply here, 8y, that's simple. Cross multiply here, remember you have to multiply the 4 by the y and the 4 by the 3. So 4 by the y would be 4y, 4 by the 3 would be 12. Okay? Then I can go ahead and solve for y. Subtract 4y from both sides. I get 4y equals 12. And then I can divide through by 4, and y will equal 3. Okay? Now, how do I double check myself? You can always plug it back in up at the original proportion. 3 plus 3 is 6. So 6 over 8, 3 over 4. 6/8 reduces to 3/4. I know I've done the correct work there. Okay? So that's how you can do the first one, number 2. Number 3, very similar. 18 times n. 6 times both terms here. 6 times n is 6n. 6 times 6 is 36. Okay? Now again, I'm going to go ahead and solve for n. So I'm going to subtract 6n from both sides. And then I want to get n by itself, so I'll just divide by 12. And you've got the answer there. Okay? Coincidentally, it's the same answer as number 2. Okay? Now for number 5, the common error on this problem is Students forget what x times x is. A lot of times they want to say x times x is 2x. No, no, no. That's x plus x is 2x. X times x is x squared. So if I put this down, x squared is equal to, and cross product here, 64. Okay? Now, most students are going to get almost everything around this problem, but one little thing, and let me show you. We know in order to undo a square, we're going to square root. So this is equal to x. And a lot of students will say, I know the square root of 64, it's 8. Well, sort of. It's also equal to negative 8. So a lot of times we write our answer like this, plus or minus 8. Now, you may be asking yourself, well, why is it or negative 8? Well, if I square 8, you know that that's 64. That's simple. If I square negative 8, okay, negative 8 times negative 8 is positive 64. Now, let's be honest. Am I really concerned about the negative version of that in geometry? No, I'm not, okay, because more often than not, actually in every single circumstance, it's going to be the positive because we can't have a negative length. But is it important for you to remember for next year? You betcha. Okay, so make sure you remember that for next year when you come back to do Algebra 2, if you're not already there. Okay? Now, for number 7 and 8, I think it's important that we continue to learn or practice factoring. I know a lot of you were talking the other day that you like the quadratic formula. It's simple, straightforward, you can do that. But we still need to know how to factor, okay? So that's why we're going to do this. So if I go ahead and factor out this quadratic right here, the question I want to ask myself is, what are the factors of 2? 2 and 1, right? What are the factors of 7? 7 and 1. Now let me put the x's here too, 2x and 1x. That equals 2x squared. Now here's my hint to you guys. With respects to the two outside numbers here in the quadratic, the 15 is a fairly large number. And when that happens, I usually put the larger of my two factors opposite the larger of the two previous factors. So again, the larger of the two factors of 7 would be 7. I'm going to put that opposite the larger of the two previous factors, which is 2. So 7 and 1. Now why did I do that? Well, let me work through the rest of it and I'll explain. Here we have a positive, so it's either positive, positive, or negative, negative. The middle term's negative, so we're going to go negative, negative. Okay? Now why did I put that opposite? Well, if you look here, 2x times 1x is 2x squared, so that's good. Negative 1 times negative 7 is positive 7. That's also good. When we do our middle term, this would be negative 1x, right? Negative 1 times positive 1x. Negative 1x, and this would be negative 14x. The sum of those two would be negative 15x. So again, I put this opposite the larger of the two factors because I've got to reach a higher number, okay? From there, the product of these two expressions, this one right here and this one right here, is 0. So either 2x minus 1 equals 0 or x minus 7 equals 0. Okay? From there, 2x, if I add 1 to both sides and then divide by 2, I know x is equal to 1/2. Here, adding 7 to both sides, I get x equal to 7. So my answer is 1/2 comma 7. Okay? It's either 1/2 or 7. Okay? For number 8, again, I would hope that you'd try these on your own first, because it's the only way to develop some confidence in yourself is when you do it on your own. But I need to set this equation equal to 0. In order to do that, I'm going to subtract 27 from both sides. I want this x squared to be positive. So I get this, subtracting 27 from both sides. All right, now, the factors of that quadratic are pretty simple. X and x would equal x squared, right? Now, what are the factors of 27 that have a sum or difference of 6? Well, I hope you're thinking 9 and 3, right? So if I put down 9 and 3. Now, the last term is negative, which means that one's negative and one's positive. If this is negative, then which one has to be the negative? It's got to be the larger of the two numbers. Okay? Now again, I always want to double check what I've done. So if I take the x times the x, that's x squared. That's good. Negative 9 and positive 3 gives me negative 27. Also good. This would be negative 9x. This would be positive 3x. Negative 9x plus 3x equals negative 6x. Okay? So we're good there. From there, all right, so from there, like I was saying, that the product of those two is going to be 0. And so what I'm going to do is I'm going to separate them, set them equal to 0. And then I just go ahead and solve for x. And so x equals 9 and negative 3. Okay? All right, so again, my goal in giving you this, I know that some of you struggle with the factoring part, but I'm really hopeful that if we practice enough that things will start to stick and you'll get it down, because again, I want to make sure you got it down for next year and the years that you follow mathematically. So with that being said, let's go to the back side now and take a look at your back side of your worksheet. This is actually the important part of today's lesson. A lot of that was just review. Again, this is also review, but I want to make sure you've got this down. And so here's what I want you to see. As we look at this is the proportion, but this proportion is equivalent to all of these other ways to writing that proportion. It's the same thing, okay? And so one of the ways to go ahead and identify that these are all the same proportions written, this proportion written differently, is to actually plug in numbers. And so if I was to go ahead and assign 1 to A, 2 to B, 3 to C, and let's say 6 to D, the ratio of 1/2 is equal to the ratio of 3/6, okay? And the reason why I want you to understand that there's different ways to write a ratio is when I put you back in groups and you start to analyze how to solve problems, maybe a person next to you is going to say, you know what, I've got this ratio, you've got that ratio, but they're not written the same way. But guess what? When you solve both of them, they're the exact same thing. So I don't want people to get confused. I don't want them second guessing themselves. I want you to say, hey, we've got the same proportions, they're just written in this different manner, okay? So what do we have here in number 1? Number 1 is just the cross product of what we have here, A times D and B times C. Again, why is it still equal? If I do A times D, that would be 1 times 6. If I use this proportion here, and that's equal to B times C, which would be 2 times 3. 6 equals 6. Nothing's changed there. Okay, it's still the same way to write that. If we look at number 2, B over A and D over C, if you look back at this original, all we're doing is writing the reciprocals of these two ratios. So if I was to flip the ratio of my numbered proportion, it would be, does 2 over 1 equals 6 over 3? And the answer is yes. So you can flip the ratio and it's still the exact same, flipping the entire proportion, each ratio. Now if you look at number 3, what we're doing here is we're writing the proportion sideways, okay? And sometimes it helps to think in the manner of the cross product. Do we still have A times B equals B, A times D equals B times C? And yes, we do, okay? The cross product's still the same, so the proportions are still the same. But if you're a person that likes to think in the case of numbers, here's what we would have. A over C would be 1 over 3. Does that equal B over D, 2 over 6? And it does. Both reduce down to 1/3, okay? So again, you can write it inverted, upside down, the reciprocal, or you can write it sideways, horizontally, all right? So in number 4, what are we looking at here? Well, we're adding the same thing to both numerators, and let's see how that would play out if we look at this proportion right here. If I was to add 1 plus 2 over 2, we have 3 over 2, or 1 1/2, okay? And if I was to do the same thing with the other one, C plus D over D, okay? We have 9 over 6, which again reduces down to 3 over 2, or 1 1/2. So All four of those ways are different ways to write the exact same ratio that we were looking at originally, okay? So how does this all play out? Well, if you look at the next section, it says this: use the properties of proportion seen above and the following statements to complete the proportions for problems 14 to 17. Oh, there's a typo. Sorry about that. Let's try 9 to 12. I don't know why that is. Okay, 9 to 12. So if we go ahead and cross multiply here, we would have 6x, right? That's what we have here. So what do you think goes on this side? 5y. Okay, just cross multiplying there. If we look at the next one, let's just go ahead and clear this off. Okay, the next one says y over x. Well, here is x over y, but if we were to do y over x, well, guess what the ratio would be for the other side? It would be 6 over 5. Again, y over x, 6 over 5. Okay. The next one is x over 5. Now, if you look at number 3, I think it was writing that ratio sideways. A over c is equal to b over d. Okay, so if we do x over 5, what we're really saying is y over 6. Okay, or another way of saying, I should say, is y over 6. Okay, so again, different ways to write the same proportion. The next one is x plus y over y. And this is the one that usually confuses some students. If we do x plus y over y, that's the same thing as saying x plus y over y. So again, 5 plus 6 over 6. Now, if you'd like to simplify that and put 11 over 6, I'm okay with that. I understand where you're getting those numbers from. So yeah, either one of those would be acceptable there. All right, now, in looking at, can we go down? For numbers 13 to 21, we want to ask ourselves if any of these proportions here, 13 to 21, are equivalent to that proportion right there. Okay? One of the easiest ways, I think, to go ahead and find this out is to actually take the cross product of each and then say, yeah, this is the same. So if I were to go ahead and take the cross product of this one, it would be 5y equals 8x. Okay? So if I want to compare that to number 13, the cross product here would be 5x and 8y. That's not the same as what I have up here. So I'm going to put no. That is not the same proportion there. Okay? If you notice here, instead of doing x over y, they're doing y over x. If I follow that same pattern on the other side, we have 8 over 5. That works. Okay? You could also do the cross product here. 5y is equal to 8x. If we look up here, we've got the same thing. Those proportions are the same, they're just written differently. Okay? Now, number 15, if I do x plus y over y, that would be 5 plus 8 over 8. 5 plus 8 is 13. And so as a result, this proportion is another way of writing the original proportion. Okay? For number 16, we have x over 5, follow that same pattern, y over 8, that's what we have there. So you could say yes, this one would work out, or you could take the cross product, we have 5y and 8x, which is what we have up there. We know we're good to go. Okay? Now the next couple, it might get a little tricky, so let's see how we got here. If I do x over x minus y, that should be 5 over 5 minus 8. Now 5 minus 8 is actually negative 3. Okay? And so as a result, this one would be a no. I could not rewrite it like that. You put down a negative 3 there, then we would be in business. Okay? The next one is x over y. Okay? Is that equal to 10 over 16? Okay? Well, 10 over 16 can be reduced to become 5 over 8. And that is what we have in the original proportion up here. So this would be a, yeah betcha, that would be a for sure. Those two proportions are the same thing. Okay? Number 19. If I do x over 2y is equal to 5 over, it's not going to be 4, that would actually be half y. It's going to be 5 over 16. And so as a result, I don't know if I want to put a cross through this or circle this and say, this one's not going to work. Okay, 5 over 16 is what we should have there. The cross product right there for number 20 says 5x equals 8y, which is not what we originally had up here. Okay, so as a result, again, that one's an easy one. That's a no-no. All right, last one, 8x equals 5y, same as what we had originally, and that's a yes, sir. Okay. All right, now the last thing I want to do to finish things off is to go ahead and look at this last couple problems down here. And as I do that, let's see here. Okay, so key terms. Scale. We're going to be talking a lot about the scale factor over the next couple of days. But to start off, the word scale compares two lengths of two similar figures. Similar figures are two figures who are the same shape, but one is proportionally larger. Okay, makes sense. Proportionally. Everything looks the same. Nothing's distorted. It's just proportionally larger. Scale drawing compares each length within a drawing and compares it to the actual drawing. Okay. Now you guys have all seen scale drawings. If you've ever used a map before, you've seen a scale drawing. If you've ever, I don't know if any of your dads are engineers or architects of any sort, you know, they've got scale drawings, blueprints. If you've ever been around your parents when maybe they've built something and they needed a blueprint for it, this is a scale drawing. So when we take a look at the problem here, here's what it says. Use the dimensions to find the dimensions of the actual bedroom if the drawn bedroom is 7/8 inch by 5/8 inch. Okay? Now, here's, again, this is how I would set this up. And if you've already done it, I hope you have. You can compare your answers and see if my way of doing it's easier or not. You know, it doesn't matter. The end result and using good logic is the key. So if I have 1 inch is 16 feet. That's what's given to us in the scale factor here. That is equal to 7/8 inch. See how the units correspond in the proportion? Is equal to x feet. Okay? And so if I cross multiply this here, your x is going to equal 7/8 of 16 would be 14 feet. That would be the one dimension of your bedroom. Okay. The other dimension can be found by doing the same thing. 1 inch is to 16 feet, as 5/8 inch is to x feet. Again, cross multiplying that, we get x, and 5/8 of 16 would be 10 feet. Okay. So the bedroom in question actually has dimensions 14 feet by 10 feet. Okay? And so, yeah, that's how you can find that out. Now, you want to make the new scale drawing with a scale factor 1 inch equals 4 feet. You want to change this for one reason or another. Maybe you're increasing the size or decreasing the size of the picture. And so here's a new scale drawing, and we use the same 4 feet. There we go. Okay. Again, one apostrophe is feet. 2 apostrophes would be inches. So 1 inch equals 4 feet. We're told that we're working with 14 feet. So the corresponding position of the feet, I'm going to put that in. Yep. There we go. Okay, and we can find the number of inches there. So if I work this out, I'm going to go ahead and do 4x is equal to 14. And so then I divide through by 4. 3.5 inches would be the new scale of that bedroom. Okay. If we continue on, I have 1 inch again is equal to 4 feet, and this time we're looking at a 10 foot. So in the corresponding position, 10 feet, x inches, And so from there I cross multiply, I get 4x is equal to 10. Dividing through by 4, you get 2 1/2 inches. Okay? So the new bedroom that you're going to lay out with the scale factor of 1 inch equals 4 feet is now going to be 3.5 by 2.5. Okay? So just, it's helpful to know how to convert these dimensions. And actually at the end of the year I've got kind of a cool project that we're going to do after we get done with this all this testing stuff that we can have a little fun with, hopefully. So I'll talk to you later. I hope you have a great night, and don't forget there are some practice problems to do for me. So thank you for being a great audience. Have a good day.